Welcome back to DX Radio Shop. On the bench today, we're going to talk about, or tonight rather, we're going to talk about the audio chips there and why they chose the TDA 2003 over the old 7222s. So the reason for this is basically, in a nutshell, because the TDA 2003 is a much better audio final than the TA7222. That's primarily what it means in a nutshell. So, but we're going to discuss more about this as to why, so you got a better understanding what the engineers were thinking when they chose to do this. Hello, John. Hello, Sylvester. Hello, Kevin. How are you? Not quite sure why. Let's see this in the live. Oh, about that right now, I guess. Anyways, so yeah, what we got going on here is very simple, really. So let's talk about a few things. First, we have a TA7222. Let me turn my phone off here. That's your TA7222. TDA 2003. Okay. Now, hello, Alan. Why they went this route versus the 10 pin versus a 5 pin is because these are a little bit more powerful, more robust, more beefy, and they can actually do a little bit more better audio output with lower distortion. Whereas these here have a tendency of having, they don't really have too much of a problem. They actually work great, but more risk to our harmonic, which they usually fight off quite a bit, but these are a little bit more sensitive, and they're less like half the wattage. These are like a 5.8 watt, whereas these run about a 10 watt. That's the biggest difference in a nutshell right there. So this is a 5.8 watt audio final, and found in most of your Culvers, Units, Presidents, etc. Right, and then this is your 10 watt. So you've already doubled your power, which is great. Okay, and so that's one improvement on top of least amount of pins, smaller package. Okay, and I don't know if anybody really knows this. I doubt it. But if you guys don't know this, I'm going to let you know anyways. So the difference of these here are basically in a nutshell, right? So these ones here are more of an integrated circuit, whereas this one here is more of a, let's say it's more robust. It can handle the overload a lot better. And so this would be a little bit more predominant than the other. And so people would want more of a peak-to-peak repetitive, there we go, onto something that's going to be constant versus something that is not. This has a loop gain control inside. It allows muting, and also it's got various protection. This one here has very low harmonic crossover distortion, that is, I should say. And this has multiple protectable circuits inside as well. It's a smaller package, but more powerful. So that's one thing among many for sure. But so yeah, I mean, it's very nice to see stuff like this. They're both a single channel type thing, but I don't know. I mean, I guess it all depends on what you guys look at. Now, these are considered as a TO220 body. Okay. And there's one thing, people don't know what they're really called. Okay. And that would be, I should ask, let me engage everybody first. What do you think this is called for the casing type? What do you think that's actually called, opposed to integrated circuit, which is an IC audio chip? What do you think this TO220 is actually called? Anybody take a guess? I'll give you a couple moments to think about that. Hey, Joker Man Electronics, how are you? I haven't seen you around in a while. Hope things are going good with you and your family. He runs a good shop down south there. And if anybody wants to check him out, check out Joker Man Electronics. He's pretty cool. Hello, Steve. We got John, Sylvester, Kevin, Alan, Steve, Jokerman, William, and David. How are you guys? So nobody's got any answers as to what this type of 220 casing would be, what they would be known as. Very popular name for these if people don't already know, which I shouldn't say that because most people don't know. So, but I'm going to give you guys the opportunity to guess anyways. So anybody who's out there who's, well, Joker Man, you're a technician, so you run a shop as well. But so if anybody knows, it's a 220 casing, but what is the name of this body, this formation of this part? Anybody know? It starts with the letter P. Anybody know? Nobody's going to put it there in the chat. No one's going to take a shot at it. You guys are all probably going right to Google right about now. See, I know this because I'm very familiar with both of these chips. These are actually used way back in some time with your car audio. So they're taking a lot of the. So let me just say this very quickly. First of all, it's a T22 casing, right? Okay. So this is actually known as a pentawatt. It's what they call a pentawatt. So, no, not PMP. It's a pentawatt. P-E-N-T-A watt. A watt. That's what it's known for. Anyway, so these are old school technology coming back to new school. So when you have your MOSFET finals that they use, the IRF 520s and so forth, those were actually, they used MOSFETs way back in the day for car audio, your car audio, stereos, all your audio circuits to drive and whatnot. They would use that to drive those like your old car stereos and whatnot. They'd use MOSFET finals. They'd use those in the car audio amplifiers as well. So when you guys have older technology, they decided to go that route because all the stuff that we were used to, like your TA7222 casing, okay, for the RF finals and like 2166s, 2312s, 1306, you got 1307, 1969s, all that stuff. So 2078s, all your RF finals, they went to the MOSFETs because one, they're cheaper, two, a little bit more robust, and three, you can do a lot more with them. So they're actually they're taking the older technology, converting it into the newer technology, and obsoleting what we've known today for our normal finals and audio chips, such as this guy. So these are pretty much just about filtered out. This one here is the takeover. And so when you have more audible control and gain, this by far would be the one to go to because your receiver audio and your output audio, this is like the really way to go. This here, your modulation sounds a lot more louder and cleaner with this guy than with this guy because he's only 5.8 watt. This one here is 10 watts. That's one big difference off the get-go. Now, this one here runs off of 4 ohm. That runs off of 2 ohm. This one here can be, well, both of them can actually be between like 7 or 8 watts on up to like 16, 17, 18 watts, something like that. So they both got the same amount of voltage drive as well. But this one here will give better amplification for your audio going out, a lot more louder and cleaner than this guy will. Now, this guy's a really great chip, but this one here supersedes him. And as you can see, the basic circuitry and what they are, okay? You can see what you've got here. This is your input. Pin 4, pin 9 is your output, and pin 10 as well. And this one also has a bootstrap inside for looping, whereas this one does not. So now, if you see the circuitry, pretty basic. You can build exactly this circuit using this chip. And I've done that many times where you've actually built something like this, and you could take and plug and play. Take your chip, stick it in, take your bootstrap to the tab for the ground, test it, see if it works. Same thing with the TDA2003. You build the same exact circuit right here, and then you can make this a plug and play. Stick one of these inside of a 5-pin connector setup and see if you have any issues when it comes to a bad audio final. So we've built many of these before. We've showed you guys how to build one. If you go back to my videos, you'll see we actually did a video on how to build one of this here circuits, and we did a nice amplification with that. We've actually tested it out, and we use it on a one of those little $5 desktop, external speakers, little power amplifier speakers you can use. We use that board there to amplify with the sound from the speaker. And we built this circuit right here into that circuit of it, and we were able to develop a way to test this plug and play immediately. So you can develop this yourself. Just copy these circuits right here and put these together, and you can plug and play this one to test or plug and play that one to test. So it's really easy to identify 99% of the time if these chips are bad. However, we did run into a couple of times where this guy was stubborn. These are both good chips, by the way. Our parts rather. This one here, we heard a pop noise in the one radio. This is a while ago. I don't know, a few weeks, maybe like a month ago, we did one. And we had found that the audio chip, it led right back to the audio chip. I kind of wondered it was. And I said, it's got to be an audio chip. And I kept thinking, well, no, I hear popping noise. And that's usually because of a capacitor. So we went to check the capacitors. Sure enough, they were leaky. They were no good. So he had multiple problems, bad caps at the output, here and here. But he also had a bad audio chip because when we had replaced the caps, it was still doing the noise. Like, what the hell's going on? And what it was doing was actually, it was creating a feedback through the chip itself. It was a harmonic is what was happening. So when we had disconnected pin 9, it went away. When I reconnected pin 9, it was right there. And what I should have done, and I didn't think about it until after the fact, what I should have done, actually had already replaced the chip and it fixed the problem. That was the last part I could figure out. And I figured that's what it would be in the beginning until I heard the popping noise. That's what threw me off. And I just ignored the popping noise and went right to the chip. I would have known right from the get-go. And what I should have done from the get-go also was test the output here with the scope, disconnect the leads from the board, and put your scope right to there and see which one had the feedback coming through. Pick up the harmonic on the scope. And that would have told me immediately, chip is no good. Which I kind of feared it would be, but then I kind of buffaloed myself. Says, no, it can't be. It's got to be the caps. I heard popping noise. And that's what threw me off for a loop because it was a harmonic from within, and it was feeding that signal out, leading to a bad audio chip. Now, these ones here don't have that problem. This one here, when they go, they go. That's it. This one, it could lead to a little bit of a puzzling situation at times, like that one did, which is like the first one I've ever seen act up in such a way that was really strange. This one here, when they go, they go. That's it. So when these go, you'll know because, again, it's a 10-watt audio final, and you're going to see a blowhole right there in the front. They get super hot, and you see a blowhole, and that usually burns out. So when these things fail, that's it. It's done. So, and then, as you can see, we have your input. You can measure your input, see what you got for modulation, and then you can also measure the output and see what your audio is. Let's say you have no sound here, right? Then you check your capacitors and see what's happening without the speaker. See if you get anything going out for receiver audio. But typically when these things go, they go. But they're a lot better, robust unit as well as far as the amplification. They're cleaner, they're louder, they're better as far as power wise. It's 10 watt versus 5.8. So you're already a lot more ahead of your game by using something like this. So that's the hot topic for tonight because a lot of guys were asking, what's your thoughts on this? Can you explain what the difference is and why they're using TDA2003? Well, a TDA2003, again, is known as a pentawatt. And so these audio finals here, rather, these audio amplifier finals is what they are. It's a TO220 casing. Now, this here small package has multiple parts inside, obviously. And so, but this chip unit, this unit right here, this device, is such a nice unit and compact that it serves multiple purposes. So the reason why they did this, because size, you can reduce the size of your radio now because you're not using something long. You can justify, let's say you have a regulator, typically on your export, Then you go to your audio chip. Then you go to your voltage regulator that feeds everything. So let's say instead of an AM regulator to this long chip over here, now you go from one part to one part to one part. Now you can actually shorten the radio back, damn near close to 2.5 inches, which is what they've done. Like your President George, your President Washingtons, the President Walkers, the Richards, the Ronalds, all of those. They've compacted them right on down. Your Striker 447s, all of those now use the TDA2003. So you can actually make a huge difference, save money, gain more, and reduce size. That's what they were after, and then that's exactly what they did. So, and they were very successful by going this route because it's really the better way to go. And they've actually superseded it by many times because they've taken old technology and said, well, what can we do? Because it's getting to be a little bit much, and we want to start making things more compact and more durable and different things with menu-driven radios, etc. So that's what they wanted to do. And they went this route because of that reason. They chose these because, again, it's more robust. It's got multiple protection circuits, very low harmonic distortion. It's got 5 pins versus 10, and it's a 10-watt unit opposed to a 5.8 watt. And of course, it's physical size. So, and when they burn out, they burn out. So they don't play games; they just go. That's pretty much in a nutshell what it comes down to. I don't know what more I can really share with you guys. On top of that, so it's kind of that's where we are. And anybody got any questions? Feel free to ask. But it's kind of a quick rundown of what they are now. What I'd like to do, and I'm not going to do it right just yet, but I got to dig them out, or I might just build 2 new ones. I don't know. I got to put them somewhere. I got to find out where the hell I did with those. I have them here somewhere though. But I have a circuit for this. I have a circuit. I know where this one is, and I got a circuit for this one. I don't know where he's at, so I may have to just build another simple one here. But what I'll do probably next week or two, we'll come back to this topic again, and I'll show you the different amplifications on the oscilloscope from this guy on the input output versus this guy on the input output, and you'll see the difference. And you'll understand a lot more why. So we will do that for you. It'll be for members only because paid members get more benefits. So we're going to do that for members only. But you can build it yourself if you wish and experiment. So, I mean, sky's the limit. You can only be successful if you give it all of your try and your efforts, right? So that's what it comes down to in a nutshell. So, yeah. The other question I had was, why do people not want to use certain test equipment? And the list was, all I see is oscilloscope, a watt meter of some sort, signal generator of some sort, and I see an oscilloscope, a signal generator, a watt meter, and I don't have the email in front of me right now. What the hell is the other thing he said? The bench frequency counter. There you go. Jeez, I'm tired. So the answer to your question is this. When you have people with the right equipment, then it shows they know what they're doing. However, for the most part, people with the right equipment, though, may not always know what they're doing because it displays very clearly the way they talk, how they maneuver around. They don't change many functions at all. And when they try to add one new function, then people get all excited, like, oh, wow, that's cool. Never saw you do this before. Pretty cool, man. Oh, you're really, like creative to all this stuff. You're like a real tech, man, because he, went from 1 + 1 to 10 × 10. So, he went from a spelling bee, we'll say apple to now spell, I don't know, Schwarzenegger, or something like that. 26 letters long. So when you see people with equipment, and one guy says, I see a few guys that have similar equipment like what you have, but I can tell they don't have a clear understanding. One of which said that he would never have a certain piece of equipment on his bench. Well, that's okay too. If people say what they say and they do what they do, it is what it is. How's that? So if you got the equipment on your bench, use the equipment. If you don't have the equipment on your bench, don't use the equipment. If you have it on your bench for decoration, make it look like you're smart. That's cool too, I guess. But learn how to use it, and it makes you smarter. Instead of looking like it, it lets you make you smart. So you got something to go on. Don't pretend. Be the real deal. Go through all that effort. Go for the gold. So one of which was the milliamp meters. He saw a video where one guy says, "You'll never see this on my bench. They are junk." Okay, that's what he claimed, and he's not the only one. I've seen it many times. People would say the same thing. This right here. That is not junk. These are really good piece of equipment to use, to test, and to set your bias. A lot of guys don't like to use it because it's very chintzy and cheaply made, but it works, and they work accurately. So the ones who argue and say no is because they don't know how to use them, and they can't compare it, and they can't prove anything otherwise if it's accurate or not. They don't understand them. That's why. So when you ask me, why do people throw these things away? How come they don't use them? They say it's junk. It's because they don't have the education to follow through. That's why. So when you see, these meters, are they good meters? Yes, they are. Do they work great? Yes, they do. Are they accurate? Absolutely. And so I've used these things for a very long time. And I've got the 100 watt scale here. I've got the 500 watt scale right there. And I also have the my bench meter I could use as well, a digital readout. And I've compared these left and right, and they all come out exactly right to a T. So like within a tenth or two of an amp, which is nothing. So basically right to a T. So yeah, I've compared these things over and over and over again. And so this is a very good piece to have. They're very small. Put them anywhere on your bench. Don't throw these away. The ones who throw these away are very ignorant. They don't have a clue. Don't do that. These are a good piece of equipment. If you don't want the 100 milliamp rather, then go with the 500 milliamp. Then you have something to work with, because sometimes people crank them wide open and you're going to be running well over 100 or 200 or 300 milliamps. So the best idea is to grab a 500 milliamp and then you'll be safe. Or grab a 1 amp and you can dial it down to wherever you want to go with it as well. So you can do it that way. But the idea is to, between the 100 and 500, I use this a lot, but I use my 500 a lot, and I'll use the digital one. It's like kind of like today, I don't know, what do you want? You want a ham sandwich? And tomorrow you want turkey sandwich. And the next day you want roast beef sandwich. That's all it comes down to. So when you see me use various test equipment, it's only because, one, I'm comparing, just to double check everything all in sync. That's primarily the reason why. And two, maybe I want to use a yellow one today and I'll use a green one tomorrow. It doesn't matter. That's my preference. But the purpose is, and the whole point is, they do work, and they are a very good piece of equipment to have. And I've seen people make these. I've made them myself out of my own personal parts and pieces, and they work just as good, right within 2, 3, if not 4 or 5 tenths of an amp. So, which is no big deal. And you can substitute that by adding componentry to make sure it is dialed right in and calibrated against with these and compared. So, but yeah, when you see these, when you guys purchase these, they ain't much, like what, $10, $12, $15 maybe, or something like that. Not much money. You can build your own, you can buy it. And these are really nice pieces to have. So when you guys want to set your bias on your radios, get yourself one of these, whether it be 100 watt or a 500 watt. Why do I keep saying watt? I'm so sorry. Jeez, I'm tired. 100 milliamps or 500 milliamps. I'm sorry, I stand corrected. Boy, my trolls are going to love that one. Anyways, so yeah, you can go with a 100 milliamp, or you go with a 500 milliamp meter, or you can use your digital bench meter. They're pretty good as well. And so I use all the above. So it doesn't matter to me which way I want to go. I can care less. They all are within 2-3 tenths of each other. So 2-3 milliamps of each other. Like 0.000 whatever the hell it was. So yeah, I mean, people who throw these away are just stupid. They don't know what they have. They use equipment. They copycat people. They don't know what they have. So that's what it comes down to in a nutshell. So that answers your question on it. And then we've answered the questions and described a lot about these here as to the audio circuits, the difference between the two. And there was something else somebody had said. in an email earlier. I'm trying to think what that was now. Oh, yeah, that's right. The span of a spectrum analyzer. How come people don't understand how to use a span? Why do they leave the machine stuck on one position? Well, that's simple. They don't know how to use them. You pretty much answered your own question. They don't know how to use them. So when you set a span, that span, whatever the number is, it's split. And so when someone says, and I've heard this before, they set it at 5 kilohertz span, and it's 5 kilohertz either side. That is not true. No. So it's 2.5 either side. It splits. So clearly, like I told everybody before, listen and pay attention and watch. And when you do, you will see the difference. Take notes, compare it. Watch a video. Now watch another video. Now watch a third or fourth video. Or maybe 10 videos. Take notes, compare it. Well, this guy said this. He said this. Okay, he did it this way. He did it this way. And compare them. And then you make your own gesture at that point as to which way you want to go and make your own decision. So make your own judgment, But I don't know. I've been doing this for 40 years. And so I've learned a lot over the years between the guy who taught me, along with many other technicians afterwards, since he's been gone. I've met up with some really good guys, and I'm friends with a lot of great engineers. I've also worked closely with engineers. I am not an engineer. Could I pass through one? Absolutely. Could I get right up there with the higher ones and work right beside them with no questions asked? Absolutely. But I'm not an engineer. So I do have a degree, yes, in electronics. I do have a trade school, same thing as a college. I do have that, and I do have my certificates and many awards and blah, blah, blah that are all certified, and they've been all proven, which is why Numbnut pretty much cut his own throat and shut right up because he's got no way of continuing on because it backfired on him. Anyway, but yeah, when you guys have all that knowledge and whatnot, then you go places. If you don't, then it is what it is. But I was very fortunate enough to, in the last 40 years, a little over 40 years, to learn, meet a lot of good people, work for a lot of good companies, and carry on. So exactly what I did. Outside of that, I don't know what more I can tell you, but that's pretty much the emails I wanted to answer. And I wanted to discuss more focused on to these guys as to the difference, because people keep asking, why won't they go back to this one? Why do they continue to use this one? What is the difference? What's so big about them? There's your reasons why. So you can Google it if you wish. You can find out more about them. If you want to type in, I don't know, what the difference is between this number, that number, or why is this one more popular than that? You're going to see a lot of different things pop up in a search engine, I'm sure. Like I said, they've both been around for a long time. But this one here is called a pentawatt 220 casing. And this one here is considered as an integrated circuit. So as an IC. 2 different packages, 2 different parts, 2 different wattage settings, current draw. They both do the same amount of voltage back and forth. But for the most part, this one's a lot more robust and a lot better, powerful audio final opposed to that one. So if anybody has any questions, drop them down below in the comments. And if anybody has any radios they need to have repaired, feel free to contact me as well. And we'll take care of it for sure, no doubt. David says, did you check out my radio? Not yet. I will do that probably, if not late tomorrow, then by Sunday. For sure, I will check it out, and I'll let you know what's going on with him. And I see Gixxer 100s in here as well. How are you? Good to see you, man. So, all right, guys. Well, I'm going to get on out of here, and I'm going to call it a night because I got a lot going on for tomorrow. All right, so this is all set over this side. Okay, he's all picked up. So anyways, yeah, like, share, subscribe, thumbs up, guys. We'll see you soon. Thank you all for watching. Appreciate that, for all your support as well. And again, if you guys haven't already joined, please do so. And you'll see a lot more definitive of information, a lot more detailed information and whatnot. Hello, Ace. How are you? Happy Friday. And so if you guys want to see a lot more troubleshooting, all the technical stuff from a real tech, join the channel, subscribe it, and hit join, and you'll see a lot more detail for sure that you won't see anywhere else. And we'll show you how to use all the test equipment. We are focused on to different aspects of certain sections of radios, along with how to use just certain parts of the test equipment, along with the whole aspect of test equipment as well, because the more you know your test equipment, the more you can do with any device out there. So we had a gentleman here just the other night was talking to me about an airport. They were using an oscilloscope trying to find out where the RFI was coming through as an interference. They think they got to narrow down, but they don't quite know for sure. And I had mentioned to him he should put an attenuator onto it, and then they can narrow it down a lot quicker. So I'm sure they'll figure it out, because those guys are the ones who designed and built whatever they got going on at the airport. So they'll figure it all out. But they used oscilloscopes to help trace the signals down. You can use it for anything. You just got to know how to use your scope. But when you have these wannabe techs that have to have the scope set up only for a couple of clicks here, a couple of clicks there, they don't have a clue. You can use these things for anything. You can use that to measure harmonics off an engine. You can use it for checking for ripples through your regulator supply, your fuse block, your starter. I mean, you can check anything you want to check with an oscilloscope, and the same thing with a spectrum analyzer. So when you know how to use your equipment to the full capacity of what it is, then you are a tech. Till then, we'll see you guys later. Have a great night and enjoy your weekend coming up as well. We'll see you tomorrow. We'll be right back out. Many more videos to come here at the DX Radio Shop.